Righty. So hi everybody, this is Nithin here. Before we start, there's a quick show of hands. How many of you are actually in the security industry? Any pen testers? Oh wow, this is perfect. This is my crowd because I can just talk anything I want. And then I assume that you guys eventually understand it, but then I'll eventually try to keep it very, very simple and then make it as informative as possible as well. So this is me, Nithin. I go by the handle of the binary bot in most of the places online. So you can find me on Twitter, you can find me on Discord. That's pretty much my digital handle. So anywhere you see the binary bot is probably me. I did my master's in theoretical computer science first. I also did my master's again in information systems management from the Uni of Galway. In fact, I just graduated like last week. And it's been a wonderful journey so far. And I'm working as an offensive security specialist at Centripetal. It's a small startup. We have 2 branches in the States and then 1 in Galway. I hold a couple of certificates, and I'm absolutely into security, anything that's security, be it defensive, attacking, be it anything related to exploits, related to research, I'm absolutely into it. But then outside work, I mostly try to dabble into photography. I try to click pictures, and that's the headshot that you saw of me. I had my camera back there. And I also do a little bit of poetry, and then I also try to do a little bit of chess. And I'm going to be here in Midlands for the rest of the night. So if any of you are staying here, and then if you want to play a game, please do reach out to me. I'm going to be really, really bored after this. So yeah, moving on to the topic. This is what we're going to be talking about today. This is going to be the agenda for today's talk. First of all, again, thanks for everybody for organizing this, and thanks to the host for giving the introduction. We'll first talk about the what's and whys of offensive AI, what it actually means to build an AI hackbot, and then we'll talk about a really unique architecture called as DSPY, and then we'll talk about how we can gather scope, how we can actually make our hackbot very interesting, very accurate, by providing it accurate sources, tools, and data, and then finally we'll close off with the best practices and a quick thanks. So moving on to OffSec AI, what does it actually mean when I say that you can build a hackbot? What is actually offensive security? So OffSec by nature typically doesn't mean that it's purely malicious. Well, you are eventually using AI, that is artificial intelligence, for malicious purposes. But you, again, we are good people, I assume. Like, we're not malicious, we're not evil. And what we are aiming to do is use AI for the benefit of the good. So when we're talking about, as you can see here, there are, again, 2 different classifications we can make. First, you can attack the AI system itself. For example, you have, now, eventually, when we talk about AI, it's not just ChatGPT, Claude. There are so many models, there are so many different varieties, and it's fast evolving. So the broader aspect of attacking AI systems would be this thing called as adversarial machine learning. And if you're actually attacking something that is more textual, as in if you're just hacking ChatGPT or any textual model, then we're talking about something called as prompt injection. You can also use your traditional web security attacks on any AI application, things like that. And you can also make attacks that's powered by AI. Now, this is where things, again, becomes very interesting, because this is where we explore areas like deepfakes. We have areas like swarm malware, et cetera, which is where you use AI, not attack AI by itself. You use AI to attack other people for the benefit of the good again. So what exactly is this AI stuff? Like, everybody keeps talking about it. And frankly, like, the people who've talked before me have made this job very, very simple for me, because you've been listening to AI every day. But AI is just like a very, very, like, it's a massive umbrella field. You have different types of architectures within it. You have the RAG models, you have MCPs, you have agents, etc. So before we get going onto the further part of this talk, we need to kind of understand what RAG, MCP, and agent is. So RAG is basically an AI architecture. It stands for retrieval augmented generation, but what it means is it has a vector DB, and it's attached to an LLM. Basically, to put it up in very simple words, you just give the AI context, and then you let the AI retrieve content for me only from this particular database. That is what, in simplified terms, what a RAG does. What it, again, helps you in doing is it helps you reduce hallucinations, right? So your AI is not going to give you false positives. I mean, it probably is going to, but then it's going to be more accurate. And then when we're talking about MCPs, we're talking about not just having an AI like GPT, right? You have to make the system connect to other applications as well. So what MCP does is it's basically just another glorified name for an API, I presume. So what it does is it helps your AI systems to talk to each other via a single protocol called as Modern Context Protocol. And then we have an AI agent. Now, AI's agent is a very, very, it's such a loosely defined term because you can define agents in different ways. But the way I see an agent is, it's like a complete autonomous system, right? Instead of asking ChatGPT to look for theaters or movies right next to you, you can just ask an agent to book tickets for you, and then it eventually chooses the lowest price, chooses the best seat probably, and then books the ticket for you. That is essentially what an agent does. It's like an autonomous workflow machine. So this is the crux of the entire AI landscape that we're talking about. So coming to the wise part, I took this picture from there. I was sitting there, and thanks to the person who was talking about this, he was talking about future tools coming soon, but is it actually coming soon, or is it already here? So this is, I got these pictures from Twitter, right? The first one is this tweet from Expo, and the second one is from Amazon News. So for context, for people who don't know about Expo, so Expo is a company. They recently surfaced. What they're doing is they've built a completely autonomous pen tester, meaning you just give the input, like you just give the IP address or the network, the CIDR, whatever range, you give web app, and it actually does the entire hacking for you. There's like very little human intervention, and it also topped the HackerOne leaderboard, as you can see here, which is pretty amazing. And they also presented this talk at DEF CON. And as people are sitting right like here, it was hacking on the background, which is extremely amazing. And Amazon, as you can see here, is also, they've been using apparently AI agents. We don't have the full picture on what exactly they're doing, but they're in the flow again. So which basically means that the why part is very, very clear. It's very interesting. It's very lucrative. And especially like if you're dealing with fields such as pen testing, bug bounty hunting, you can mint money by just basically running your agent in the back. Now, what does it mean to me? What does it mean when I say make it agentic, right? We've talked about RAGs, we've talked about MCPs. Now, what does it mean to say that what does it actually mean when I say make it agentic? So again, to make it agentic means to reduce human interaction at the very best possible, right? So this, you can consider agentic as to be the evolved version of an agent, which not only plans your activities, but it actually autocorrects, it also adapts, and it also reasons, and it works towards your goal without you having any interaction. So this is basically the equivalent of saying no human in the loop sort of a situation. So now let's talk about how we can actually build this stuff. Now, to be very honest, if I had the answer, if I could make another Expo, I don't think I'd be standing here. I would probably making it there and then minting money. But I've been trying, and I've learned a bit. So that's what I'm trying to explain here. And eventually, if any of you are really, really interested, we can again brainstorm after this talk. So the first question being, why can't you just use ChatGPT? It pretty much knows everything, right? This is a question that I was presenting this talk to my flatmate before coming here. This is what he asked me, like, bro, yeah, all of what you say is pretty much true, but why can't I just use ChatGPT? Why can't I just ask it to hack something, and why can't it hack? And when he asked this, I asked ChatGPT to ask me to define what MCP is. Can anyone find what's probably wrong here? Sorry? Exactly, designed by OpenAI. So ChatGPT said MCP is designed by OpenAI. MCP is designed by Anthropic, and Anthropic is OpenAI's competitor. Look at the hallucination here. It probably is going to do the same when you ask it to hack something or when you provide it data. This is something that I just did, so I didn't give it any context. I just asked it to define OpenAI and give it simple explanation and give a technical explanation. This is pretty much what it did. So if this can happen to just a simple concept as an MCP, imagine what kind of hallucination, what kind of accuracy it gives you for something that is going to be very complicated as attacking an actual application. So this is where this concept called as context engineering comes into picture, right? Because when you just specify ChatGPT or any other AI agent to give you some data, it's just going to give you data from raw internet. It's going to parse whatever it finds. It's going to parse whatever is probably latest. And it has its own bias as well, like how you saw the OpenAI stuff. And then it's just going to give you inaccurate information. So this is where this topic called as context engineering comes. And pretty much context engineering is what eventually makes your hackbot, or it probably also breaks your hackbot. Because context engineering is not about just the way you design. It's not just about the way you set up your AI hackbot. It's about how you actually make it. It's about essentially how you give it more context and then make it more niche, make it more nuanced to eventually make your hackbot very, very accurate. Because at the end of the day, we want our hackbot to be fast. We want our hackbot to be working, reliable, and all of that is true. But then the first thing that we want our hackbot is to be very, very accurate. We don't want it to give us false positives. So there are a couple of things you can do to make your, to basically provide your hackbot more context. I have a couple of tips here. Now, the first one, what you can do is you can basically give your AI hackbot more context than that which is actually required. For example, let's say that you are writing a program, or you're writing anything whatsoever with respect to any language. You can, and let's say if you want an output in a certain field, like in a certain structure, I would probably provide the output in a way that I want as well. So that is adding an extra layer to it. Which is very simple as saying, say, for example, you're trying to build a booking application, and then if you want to store all the data structure in JSON object, don't just ask the AI agent to just build a booking application. Define the structure, define the schema you want, define the kind of DB you want, et cetera, et cetera. Just give more information than it's absolutely necessary. And there's this neat trick that I found from Jason Haddix, who works in Arcanum Security as well. And what he does is he uses this thing called as related search terms. And what he eventually does is he puts all of the, for example, when you are building an AI hackbot, you have to make it like very niche, very nuanced. And for example, I'm very much into web security application hacking. And whenever I try to find any resource related to web application security hacking, I provide all of these search terms as a system prompt. So what this does is it makes the AI system think into that mental neighborhood, in that small neighborhood of data. And then it's going to provide you more accurate results than just querying it from raw internet. So that is another thing that you can do. And finally, you can also have custom RAG packs for custom agents. What that means is, right. So custom RAGs, what does that mean? So RAG, as we saw before, stands for retrieval augmented generation. But what a clean RAG actually aims to do is it aims to reduce noise. And when you have different RAG packs for different agents, and when I say different agents, I'll show you an architecture of something that I was trying to work on later. But when I say different agents, you're probably going to have one agent to just report something. For example, let's say you did an entire pen test, and if you want to make it into a report, you're going to have an agent for it. For just running tools, you're going to have another agent. For just running, I don't know, probably maybe some scripts, you're going to have another agent. So the more nuanced or the more narrowed down your agent, you can make your agent, is the better for you. And then eventually you're also going to normalize them, and then you can use another AI to clean them, et cetera, whatever. But the idea is to have a knowledge base for each and every single specific agent that we're talking about here. So for example, let's say that if I have an AI agent for just reporting vulnerabilities, right? What I'm going to do is I'm going to use all the resources from different reports that I can find online, all trusted, verified reports, obviously. So I can go to places like Buckroad, HackerOne, HackTheBox, etc., whatever I can find, and then I'm going to use all of these previous pen test reports, and then I'm going to store them in a vector database, and then I'm going to ask it to query only at those databases. So it makes it very, very, very accurate as opposed to scouring the raw internet again. So you can have another agent to only switch your HTTP methods. It can be as niche as that, but then that doesn't make sense, right? You can just basically write another script to just switch your HTTP methods whenever you want to. So you don't need a RAG for that. So you have to clearly identify to what you need to have a RAG DB, and then for what agents you don't need a RAG DB. So that's the premise of having a custom RAG. Now moving next, this is very, very interesting. This is probably the crux of this entire talk. So I came across this library or an architecture called as DSPY. It's basically a Python architecture. What it does is DSPY is basically like a new library that's been emerging, that's been talked about very much recently. To define it more detailed, it's a modular framework where you can define signatures, you can define what's called as DSPY modules, you can define what's called as DSPY optimizers, etc. And it just helps you make your AI Hackbot more accurate, but then you just don't say it in a textual manner, but then you give it actual program. You write program in Python, and then you architect it the way you want it to respond. And then DSPY is available for different models. As you can see here, you can use OpenAI, Anthropic, Databricks, Gemini, etc., etc. This is very, very interesting again. I haven't made the best possible, like I can talk about DSPY all day, but then I only have like 30 minutes. So I'm going to quickly run through DSPY modules and DSPY optimizers. So what DSPY modules does is it helps you to describe your AI behavior as code and as not strings, right? So again, here is a small example of a DSPY chain of thought function or a chain of thought module. So as you can see here, what we're trying to do here is we're at the URL, you can enter any IP or port wherever your DevFest wiki is hosted. And then you can, like when you give it a chain of thought here, what you're asking the agent to do is you're providing it context first, and for every question you're asking it a response. For example, let's say if you want the response as a JSON statement, you can add a colon there and then specify JSON. If you want the response as numerical data, you can specify colon there and then say float or int or whatever data type the DSPY intakes. Which is again Python, so you probably have everything. And then when you ask a question, what this is going to do is so it's going to go to that particular wiki, and then it's going to do its chain of thought and then give you just the answer. It's not going to, again, go to the entire internet and then going to find, it's not going to go to LinkedIn, look at all of the DevFest speakers and then try to make its own assumption. So when you ask a question like this, it's going to answer my name. And then moving on to DSPY optimizers. Right, so we have functions, which is called as DSPY modules. And then we have DSPY optimizers, as the name sounds, which is very, very nice, very self-explanatory. Optimizers essentially what they try to do is they optimize your code. They optimize the way you give your prompts. And then to, again, make it very, very simple, what an optimizer does is it fine-tunes your prompts. So in the previous question, we asked the question as, what's the name of the presenter who talked about engineering hackbots? So when you have something like this, and then when you add an optimizer on top of it, what it's going to do is it's going to know that you are in the context of DevFest, or it's going to know that you're talking about this particular field. So when you ask another question, which is probably not there in the wiki, it's going to fine-tune its prompt, it's going to correct your steps, and it does the auto correction part as well, which is very, very interesting. And then you have different examples as well. You have DSPY Bootstrap RS, which is an optimizer. You have Bootstrap fine-tune. So what the Bootstrap RS does is it takes a few short examples, which is basically another fancy word for examples. So it gives more examples to your prompts, and then the more examples you give, it's going to understand that this is what this person is expecting, this is what I have to give him, and then it optimizes your code accordingly. So that is what an optimizer does. But again, DSPI is very amazing, very, very good. I don't think I've made the best possible explanation for it, but you can always go out and check at dspy.ai and then explore more about it. But again, as any program, you have lots of caveats and pitfalls associated with it. First being, it's a purely text-only framework, right? So it's definitely going to work well when you ask it textual data, but then when you have, like, let's say you have a PDF and then you want to give that as your chain of thought, it's probably not going to work because it only works for text-only framework. And then you also can't do broad wrap integration because it's, again, only a text-based framework. So it's very good for research purposes. It's very good if you are building something on your own, but then it's not probably as good as an XPerf agent, which is production-ready AI Hackbot. So now the next question being, how can you make it production ready? Can you just simply use DSPY? Is it enough, or should you rely on some of the tools, scopes, data sources, etc.? Now this is again one of my very interesting arguments, one of my very, this is something that I pretty much talk to anyone about. When do you have to use automation? When do you have to stick to AI? This is my personal opinion. You can differ, you can fight me, you can debate me. I'll be outside the hall after this talk. But I think you should be using automation when you have the result which is completely predictable, right? When you don't need a model to reason, when you don't need a model to summarize, when you don't need a model to explain what's there, when you know what the answer is, when you know what the structure of the answer is, of the response is going to be, in that context, you can use automation. Not like you can use, you have to use automation because it gives you better results. When you need to use AI analysis is when you need more data interpretation, when you need to, let's say, summarize data, when you have like a chunk, like a massive load of data, and then you have to make your own reasoning, you have to predict something out of it, things like that. That's when you have to use AI-led analysis. And when I talk about this to people, they ask, again, without understanding, they ask me if I can completely replace automation with AI. That, again, doesn't work, at least not in my opinion, because, again, your AI hallucinates a lot, irrespective of whatever RAG, whatever you throw on top of it. It's either going to be slow if it's consistent, or if it's not slow, it's going to hallucinate and then give you the answers that you don't really expect. So what you can do is you can put AI on top of automation. You can clearly define all the scripts. You can clearly define all the code you want to write with the predictable output that's in your head. And then you can put AI on top of it to just summarize, clean the data probably, make it structured, etc., whatever. I don't think you should be using AI to reason when the output is not predictable. So that is what I meant by the AI versus automation-led theory. And now what you can also do is you can also microscope all of your vulnerability agents. So again, as we talked about, you can make the agent very specific to one task. For example, if you don't build a specific agent to perform SQL injection, or don't build a specific agent to do XSS, make it very, narrow that down as well. If you're doing SQL injection, make an agent to do blind SQL injection, make an agent to do reflective XSS, etc. Scope is very directly proportional to accuracy. The better scope you give, the more narrow down you make, the better accuracy you have. So this is an architecture that I was talking about. It's actually not my architecture. It's this architecture from this person called Rami from UltraRed. As you can see here, you have different agents doing different things. A couple of caveats here. Again, you don't have a RAG DB here. You have an orchestrator agent. You have system prompt agent. All of this is good stuff. So this is the base I had when I was trying to build my stuff. And all of this is very, very interesting. Like, you pretty much, in almost any Hackbot that you're building, you definitely need an orchestrator agent, which is like the centralized agent which plans, which executes things for you, which tracks the global state. it's like this one puppet agent, which you can just swing your strings and then ask it to do whatever you want it to. And then you need a pre-planner agent, which talks directly to the orchestrator agent as well. A pre-planner agent is the strategist of sorts for your entire agent. It kind of decides what's the next task you have to take, what's the kind of output that you're expecting from an agent. And then it also tells all of your other agents to not just pray and pray, but actually do the task what it's supposed to do. The rest of the things is completely self-dependent. If you need a result parser, you can have it, or if you have already defined the structure very clearly for every single tool you have, you don't probably need it. But yeah, this is like an example architecture that you can follow. Very, very interesting. Again, big shout out to Ultra-Red and Romy Hype for this. Now, finally, moving on to data sources, you can, now the real question being, how do I build this, right? We've talked about architecture, we talked about different models and etc. But then how do you actually build it? Like, you have so many different possibilities. You can use LangChain, you can use Cloud Desktop, you can use Cloud Code, and then mix it up with MCPs. But personally for me, I think the Cloud Code plus MCPs has worked the best for me, because you can also make it autonomous, and then you have multiple MCPs that you can just play around, you can eventually adapt, and it's just fun playing around, right? And then for RAG data sources, at least for OffSec, I would recommend checking out HackerOne, ExploitDB, SecList for word lists, fuzz lists, and then also check out research blogs or presentations, and then put them all together as a vector DB. And finally, to close out the slides, we're just in time, okay. For context engineering, I have a couple of best practices as well. The first thing you would probably want to do is give your agent more examples, because examples always beats instructions. Don't ask your agent to do this, do that. Ask your agent to do this, do that in this manner, and then it clearly understands what you wanted to do. And then also define your output very, very clearly. Is it a JSON schema that you're expecting? What headers are you expecting for each request? And then also a couple of watchouts. Make sure that your agent is not running too long. Always have a kill switch, and then always double check, verify your output. That's where the human in the loop comes in. So for every output, it's always better to just go on and check. And always just do context engineering, guys. Don't just ask the AI to do things for you. Make it very specific, narrow it down. And if you have any questions, I would appreciate that. But if not, I'll be anyway here around. Feel free to have a chat with me. That's my LinkedIn and Twitter if you want to connect. But otherwise, thank you. It's been a real pleasure and fun talking here. Thank you.